Welcome back, class 10th. In our previous chapters, we have successfully completed our half part, means unit 1 of chapter 4 calorimetry. Now we are moving to the next unit of the chapter 4 calorimetry again. In the previous lectures, if you remember, in the last lecture I have solved some numericals and I am waiting for your problems and queries. I wish that you all are going through the 10 years question of board examination. Something different type of question are asked in the examination, so please go through and then put some question against me. Now, what is our next topic, today's topic? That is change in phase. Change in phase means state change. State change means from one means solid to liquid, liquid to gas, or reverse process, or direct to whatever. This is the change in state. So for that, to start, we must understand the melting, boiling, what is melting point, what is boiling point. So what is melting? Melting means changing from solid state to liquid state, known as melting. Simple definition. From liquid to gas, called boiling. Reverse from boiling to liquid means called condensation, and from liquid to solid called freezing or solidification. Every state change has a two name, but what our main topic is about melting point and freezing point, boiling point and condensation point. What is that? Point means doesn't mean that it's a point. Here definition it is having the point word. If I'm talking about the melting point, it means it is the temperature, a constant temperature at which the solid changes to liquid state, called melting point. For example, ice at 0 degrees Celsius melts to be water at 0 degrees Celsius. In this change, what is the temperature? 0 degrees Celsius ice changes to 0 degrees Celsius of water. The temperature was constant, but stage is changed. So this temperature 0 degrees Celsius, this temperature is called melting point. So if somebody asks what is the melting point of ice? 0 degrees Celsius. The reverse process, the water at 0 degrees Celsius freezes to form ice at 0 degrees Celsius. Again the temperature remains constant. So liquid changes to solid. So what is freezing point? 0 degrees Celsius. So at a constant temperature, when substance change from one state to another, at constant temperature, that constant temperature is called whatever point. Point means the temperature, and whatever point means melting, freezing, condensation, whatever it is. So if it state changes, the constant temperature will be known as particular point. Okay. Now our next topic is determination of melting point, freezing point, and many more, boiling point. Means we are going to see some special curve. I will speak the name after some time. Before understanding the curve, just see here. This is the graph between the time on the x-axis and the temperature on the y-axis. Suppose you are heating any substance, you can take water. Let's start with the water again. So if you are heating water in a pan, so what you are supplying? You are supplying heat energy, and due to that heat energy, its energy will increase in the form of temperature that you can see. So suppose the x-axis, which is our time axis, on giving heat with time, what will increase? The temperature. So you can see the temperature is rising up to 100 degrees Celsius. But after 100 degrees Celsius, the temperature rising stops. That becomes constant for some time. See this? But if you are heating, then after some time the curve starts rising. Means again the temperature starts rising. What does it mean? During that, when the line was horizontal, are you not giving the heat energy? That is why it is not rising? No. You are supplying the heat energy continuously. In starting, the temperature was rising, but after some time the temperature becomes constant. Then after some time again, the temperature starts rising. What happened during this time when the temperature was not rising? As I said, we are supplying heat energy. We are supplying heat energy, but that energy is not visible in the form of temperature, in the rise in temperature. It means that heat energy is hidden, not visible to you. And that heat energy is called latent heat. Latent means hidden. Remember this. Latent means hidden. That hidden heat energy, what happened? Utilized to change the state of the substance. Again see, in this curve, if I am starting with O, then A, then B, then C. So that AB curve shows what? The energy was given is hidden right now in the form of potential energy of the molecule. If the temperature rises, it means the average kinetic energy of the molecule rises. But duration in the duration of AB, in that section, the heat energy is utilized to change the state. Means suppose we were using water, so from 0 to 100 degrees Celsius, the heat energy was visible in the form of rise in temperature. But from A to B, the heat was not visible in the form of temperature. At that time, the water was changing into the vapor, into the steam. So, if the reverse process goes on, so see here again, the reverse process goes from some temperature to 100 degrees Celsius. Means you have stopped the burner, you have switched off the burner, so the heat energy will radiate, the water will cool down, the vapor will cool down to form water again. So you can see the temperature was falling up to 100 degrees Celsius. But after 100 degrees Celsius again, it becomes constant. Why? That vapor was changing into that steam was changing into the water. Means the energy was utilizing, means liberated to change the state from gaseous to liquid. Then again the curve shows that the temperature is falling. Means again the water was decreasing its temperature. So that section in which you will see the line is horizontal, you will say that this is the change in state, and that heat energy is hidden. That is called latent. Latent has synonyms hidden. So that heat is called latent heat energy. Clear? The heat which is used to change the state will not be visible in the form of temperature. So that will call the latent heat. Okay? So the curve that you have seen, rising the temperature and falling the temperature. The rising one is called heating curve and the falling one is called cooling curve. Okay, that's just a name, heating curve and cooling curve. Our next topic I want to discuss about what is, again, if you want, if you have to write the definition of latent heat, what you will write. I said in the starting of this chapter, if you remember the definition of 1 calorie, all the definitions are related to this definition. Same way here also. What is latent heat? The amount of heat energy required to change the state of a substance at a constant temperature. You know that change in state is at constant temperature always. So the amount of heat energy required to change the state of substance at constant temperature is called latent heat. Means the heat energy which is required to change the state is called latent heat energy. Now in this definition I was not talking about the mass. Now let's talk about the mass also. If you are specifying the mass, then this definition will change to specific latent heat. Okay, specific latent heat. Now if somebody asks, so what is definition of specific latent heat? So you have just introduced one more word, that is called unit mass. Now I am speaking the definition. The amount of heat energy required to melt 1 gram or 1 unit of solid, sorry, not solid, substance you were saying. The amount of heat energy required to change the state of a substance of unit mass into the another state is called specific latent heat. But in examination, only specific latent heat will not seen. It will be written like specific latent heat of fusion, specific latent heat of freezing, specific latent heat of vaporizing. So what is that? A specific latent heat of fusion means the substance is melting. So at that time the definition will be the amount of heat energy required to melt a unit mass of a substance at a constant temperature is called specific latent heat of fusion. Why specific? Because I said unit mass. Latent because it is hidden. Unit mass, that is why it is specified. Okay. Again, after specifying, suppose I am introducing one more word about the substance. I am speaking, listen carefully. The amount of heat energy required to melt unit mass of ice at a constant temperature is called specific latent heat of fusion. Now you will say fusion of ice because I have explained about the substance also. When you will talk about the substance, that is general. When you will talk about a substance is ice, then you have to write the specific latent heat of fusion of ice. This is the new word. Now we have to talk about the expression of the heat, latent heat. If you remember the last time, the heat energy was having the expression H is equal to mc theta. If you remember, this was the expression for normal rising temperature or falling temperature. But here there is no rise or falling temperature. If you are using that theta, means theta is what? Change in temperature. Here there is no change in temperature. Theta is 0. If you will put theta 0, then you will get H is equal to 0 and you will say no heat is supplied. The answer is no. Heat is supplied, but that heat is hidden. That is latent. So that expression will change to the new. This time the H will be equal to M into capital L. What is H? You know heat energy. M into capital L. What is H? You know heat energy. What is M? The mass of the substance. And what is L? L is called the specific latent heat. As here the C, the specific heat capacity. Same way the L is what? The specific latent heat. If there is a rise or falling temperature, so you will use the above equation that H is equal to mc theta r or theta f. But if there is no change in temperature, means there is state change, then you will use Q is equal to ml. So now you have to understand the process of a substance. Suppose you are taking an ice at 0 degrees Celsius and that is melting right now. So which expression? H is equal to m into L. And now after melting, the temperature will rise. So at that time, which expression? H is equal to mc theta. Now further keep rising the temperature. After, means when the temperature of water will come to 100, again the temperature will be constant. Then again what you will use? H is equal to m into L. Now if after 100, when the water will start boiling, then when the water will start boiling, then at that time what will happen? The temperature will start rising, then again we will use the above H is equal to mc theta. So here we are talking about the expressions. Now let's talk about the unit. As I said, latent heat energy. We know that always the heat energy is measured in joules. SI unit it is. So again here the latent heat will also have the same unit, that is joule. So H is having the unit joule. M is having the unit kilogram in SI. What will be the unit of L? L is what? The specific latent heat of fusion or freezing jobi. But we are talking in general. L is what? The specific latent heat. What will be the unit? L is equal to what you will get? You will get L is equal to H upon M. H has a unit of joule and M has a unit of kilogram. So L has unit joule per kilogram in SI or joule per gram in CGS. So these are about the latent heat, the fusion, the melting. Again I want to point out what you have to remember. First thing, If the substance is rising its temperature, you will use H is equal to mc theta, or falling temperature. And if the substance is changing its state, then at that time you will use m into L. Remember this point. At a constant temperature, if you are writing H is equal to mc theta, then you will get theta 0 and you will get answer 0. That's incorrect. So always state change ml, rise in temperature mc theta. Where is that heat? That heat energy is hidden to increase its potential energy of the molecule. And if the temperature is rising, means the heat energy is utilized to rise the average kinetic energy of the molecule. That is why it is visible in the form of temperature. But if it is not visible, means that is hidden, means that is latent heat energy. Now let's have few numericals based on this topic. Here we have the practice problem 1, chapter 4, calorimetry, unit 2, change in phase. I am going to solve the question number 2. A solid of mass 80 gram and at 80 degrees Celsius melts completely to form liquid at 80 degrees Celsius. See here, there is no change in temperature, means there is a change in state. By absorbing 640 joule of heat energy, means that is latent heat. What is the specific latent heat of fusion of solid? So let's write what is given. As it is written here, 80 gram is the mass. So you will write m is equal to 80 gram. At 80 degrees Celsius, it forms liquid at 80 degrees Celsius. No, you will not write theta because it is 0. By absorbing 640 joule of heat energy, it is melting by absorbing this, means this is latent heat, and both are having same figure, same letter. So this is 640 joule. Then what is the specific latent heat? Means asking about the L is equal to question mark. So let's write, as I said, if there is no change in temperature, means then what you will use? You will use H is equal to m into L. Fill the values. H is 640, m is what? 80 only, and L we have to calculate. So L is equal to 640 upon 80. The unit of 640 was joule and the unit of 80, this is gram. So 1 0 cancel, 8 8 is 64. So L is equal to 8 joule per gram. So this is the specific latent heat of fusion of solid. If this would be ice, then you would say specific latent heat of fusion of ice. This is joule per gram. If you want to write in kilogram, so just multiply with 1000 because gram in downward. So on dividing, further divide goes to up. So that will be 8000 joule per kilogram. But it is asking only about the CGS unit. So this is perfect answer. Here I am ending this session. I have solved only one numerical because I am waiting that from your side you will solve some numericals after this practice problem, and you will inform me that you are facing in this practice problem or that. Else I will solve just normally as I am doing. So till then I am waiting that from your side. Be safe, take care. Thank you.